So this is actually also in the generative AI space. This is probably one of my first meetups. I've had a lot of meetups in with respect to data science and other stuff. So this is basically what happens is when you try to with these new language models which are you can say RLHF tuned. Whenever you try to ask them on anything which is related to recent topics, they either give you something like this or something like this. So I just typed this Sam Altman ETQNA on Notion AI and this is what they gave me. It's pretty convincing, but none of this is right. In fact, in one of the ones I actually asked them, like, they mentioned that Sam Altman is in favor of work from home policy when he's actually come out and said that no, actually we don't favor work from home anymore. So this is basically one of the challenges that you face. So how do you go from that to say something like this, which is more factually rooted? It still gives you like a free form writing, but it still manages to ensure that it gets those facts in. This is basically one of the main topics of when you use large language models is how do you make it centered to write on fresh content or your custom content in order to make sure that it doesn't hallucinate or doesn't go overboard or doesn't try to put in some random facts. Going to it at zero is not 100% possible, but you can. There's a lot of tactics that you strategies that you can use to do that. So we'll be discussing some of them today, and like with all of these strategies, implementing them in production has one or two main constraints, and that is what is the cost that you can afford and also how much time this takes. So all of these things have to be factored on that. So we just go forward. So just before we start, anyone over here who is for whom this term is actually new, retrieval augmented generation? Okay, so I'll just give you a small introduction. So retrieval augmented generation is not, so this thing came out when GPT-2 came out, and what basically happened was GPT-2 was pretty good at writing, but not as good as GPT-3 and definitely nothing close to GPT-4. But what the thing was that people were trying to make sure that okay, what if we try to make it right on our custom topics and make it hallucinate less. So there were a lot of tricks tried, and there was a paper that was released on this topic in 2020. I think it was released by Facebook or Meta as we call it now, and basically they trained two models. One was a retriever model and one was a generator model, and the whole purpose of that was, given a data source, just retrieve the relevant pieces of information that you can pass to your language model, nowhere near as large as this, and try to make it generate text. So there was a lot of stuff done, and if you were to experiment with open source models, you will see the old DPR models on Hugging Face. They are there, and they're actually pretty decent when it comes to this retrieval augmented pipeline. Then GPT-3 struggled with this, even if you tried this. But when GPT 3.5 came out with the Text DaVinci 002 model, Text DaVinci 003, ChatGPT, those models, they actually started being really good on user instructions, and they also were very good on reading data from a specific context and answering based on that. And that is where this whole retrieval augmented generation took another level, because you have your retriever which fetches relevant sources of data, but for generation you have the power of a large language model like GPT-3 or GPT-4, not 3, 4, let's put it this way, 3.5 and 4. And so with that you can actually generate pieces of text on recent topics which don't hallucinate, which you can also customize to your format and you can also then add citations. So it looks like a legit piece of writing, which is actually passable, which is actually usable for your stuff. So this is what we do, and in this talk we'll focus on retrieval augmented generation for topics where we have to fetch data from search engines. So there are multiple things people have done. Search engines, they have your own data sources like PDFs and Google Drives, etc. So we'll focus on search engines for this talk, just to keep it simple. So there are different strategies, and so we'll start with these strategies. Strategy 1 is what ChatGPT has used with the browsing. So how many people have the premium subscription of ChatGPT? Okay, so if you use the premium subscription of ChatGPT, one of the features they have is ChatGPT with browsing, and basically what they do is based on your whatever input is there, they will try to search Bing, because Microsoft for them, and they'll retrieve stuff over there, and based on the data they receive, they try to scrape the links, and then they try to answer the questions, answer the whatever input you have. So let's look at how they're doing it. So we don't have the exact algo of how they're doing it, but we can sort of approximate how they're doing it. One of the stuff they do over here is, say, suppose this question is there. This is one of the stuff which, when you try to put factual data, we just put it over there, and what they do is they converted that, if you can see over here, this input they converted into a query which they put on the search engine. The other thing what they do is, let's put it over here, one second. They converted that into, so this is ChatGPT from a week ago, they keep improving. I'll show a demo of this also afterwards. So what they did is they converted this into a query, and then what happens is, whenever you have a query, you will obviously on your search engine page you will have your different links. So what their strategy is to try to click on the links, scrape it, and use it for answering your questions, your input. So their strategy usually is to use the first link, because they like what they've done is based on the first link and try to scrape it. If it doesn't scrape, then try to scrape the second link, but at most what they do is they scrape one link, and based on that they'll try to generate your response. So this is one way to do it. You can have various APIs, so you can just convert whatever user input is there into a query, and using the query you hit a SERP API, search engine API, you get the results, scrape the first link, that is your context, and then you pass it to your GPT or whatever model you're using and try to generate an answer. So this is one way of doing it.
I have a question.
Yeah.
How does GPT know when to search? And so if it is less confident of the response, then it searches the browser.
Yeah, this is how they're trying to do it.
Like, as in, how does GPT know when to trigger this browser search?
Oh yeah, so we'll get to that. So they have a way of doing it where they do it through prompts. So you will have agents to do it.
If there are certain keywords, like do they like code in, let's say something like Russia?
No. It's not like that. It's through prompts. We can discuss this afterwards. This is slightly unrelated. So that is one way to do it. Now, one thing over there is, if you've used ChatGPT with browsing, one thing you've noticed is so this strategy involves that the link they click on should be, we should be able to scrape it. And a lot of times the issue that happens with ChatGPT with browsing is that they are not able to scrape the links. So they try to do a strategy where they try to go through the full first page and see whichever link is scraped, and they use that for the response. This actually this is sort of a high risk thing. Like, it works, but there's also a risk involved. Is what if you're not able to scrape the link, so you won't be able to answer it, and you won't be able to feed the relevant information over there. So this is one way to do it. Now the other thing was, so this is basically your search engine page. So I'm showing one second. This is your search engine page over here, and one thing which you see is in the search engine page, not only do you get links, but you get stuff like this. Like this is a featured snippet, which is your answer, which usually you get now. And then you get these people also ask, which are questions over here, and there are about 3-4 of them generally every time. So one thing which you can definitely do is, can you give this information to GPT and ask it to write an answer? This is one strategy which ChatGPT with browsing doesn't use, but this is one strategy you can definitely use. The point is to feed as much data as you can to your large language models when it comes to for generation, because the more data you put in, the more it's able to see it's able to see how relevant it is. Now obviously you have a constraint, like you can't put unlimited amount of data because they're restricted by a context length. But this is one strategy which is there, which you can use and put it in this. And this is one of the papers which was written last year, which was self-ask with search. And what they try to do is they try to do this process itself, where you ask a question. What they would do is you would pass an input over here, which they assume to be questions. It works on questions. And what they would do is they would divide it into sub questions and try to answer each sub question. And once those questions are answered, give a final answer. So I'll just show a demo of that, which would make it a little more clear. So is this visible? Okay, let me just increase the size. Yeah. So this is basically your prompt which they are passing to GPT over here. They've used the GPT-3 models over here. This was written last year, and this works well on the GPT-3 models, the 3.5 models. So you pass this prompt to the LLM, and then you can pass this thing. Oh, 1 second, let me just show you your question. Now, in normal circumstances, what happens is if you just run this as it is, this is what's going to happen. It's going to make its own stuff over here based on the prompts. But this is not what you want. So what we can do over here is, if you see the prompt over here, and you can see different patterns. So there's a question, there's a follow-up thing, follow-up tag over here, which is follow-up questions needed, and then you have this intermediate answer. So one thing which you can see over here is, based on your question, they're dividing it into sub questions, and they're trying to find the answers for those sub questions via the search engine. And then what happens is, once you combine these answers, the model itself is able to understand, based on the above information, can I generate a final answer using the above information. So this is one approach which they used for answering questions. So we'll just start this. So, and we'll do this in a very simple way. Instead of generating the full thing, what we'll do is we'll ask it to stop at this place. Just put a stop sequence. Reduce this up. Actually put this down to 0 and see what happens over here. Okay, So it stopped over here. It didn't generate the intermediate answer. Okay, so we'll put it over here. And then we'll ask this question to a SERP API. So these are different SERP APIs available in the market. So the SERP API is one of them. There are different APIs over there. What they do is basically they mimic your search. So your search engine is over here and they mimic that and return the response as a JSON object. So the whole point over here is, what if you can ask whatever user input is there to the search engine, get a response from them. That is your retriever. You feed it to your large language model and ask it to be a generator and generate the response. That's basically the whole purpose of trying to do retrieval augmented generation, to try to get it to answer on recent topics. Cool. So now you have it divided into 2 questions, and now let's see what happens. Okay. So no answer snippet, but you do have few things over here. You have the first snippet over here, and you also have these people also ask. So according to their algorithm, what they did was they'll take the first result. So the first result is the first snippet over here. So just take this. This is an incomplete answer, but we'll still use it. So as you can see over here, using these different pieces of information, you were able to come to a final answer. So this was basically self-ask with search. This approach was released sometime last year, and basically it was a way of trying to split your user input, try to ask questions to the search engine, try to ask simpler questions to search engine where you can get an answer, and then try to combine them to get a final answer. This was released last year, and it was fairly this splitting things into questions and asking different queries so that you can get more pieces of relevant information is something that's actually pretty valuable, and it's been used not just in this, but a lot of people have used it. In fact, we've also used a variation of this, not this exact, because this has one limitation, is that it works mostly for questions only. And they actually released it as a paper, and they open source the code, so you can you can go on the repository, you can just clone this code and you can just run it, and the same thing happens over here. In fact, we can just do that over here. They are basically doing the same thing over here. They're trying to generate questions, get the intermediate answer, append that to your prompt, try to ask, get more follow-up questions and get it over here. So it's kind of like acting as a mini agent of sorts, trying to combine different things and trying to get this thing generated. And this is one way of how you can get it to answer questions on recent topics. But there's one limitation over here, is this works on questions, and if you ask it a free form input, then it sort of fails. This approach fails. But still, one thing is there, that this approach of generating questions to fetch results is still actually pretty useful. And this was one of the things that when we were playing around trying to see how to make our application, which was late last year, on this, was can we do this on getting this. So one thing which we realized is, okay, so you have your search engine API, you hit your search engine API, you get your answers, you get those questions. They haven't used those questions, but these questions people also ask. These are actually still pretty relevant, and because it's indexed by Google, that in quality wise also they're pretty relevant. So you can actually use this as this, and you can maybe try to pass this as a piece of information. You can also maybe scrape the links also. Now scraping one link, there's a risk. What if you scrape maybe 1 or 2 links? And since you have multiple questions generated, you scrape the links, you take the question answers, so you have a pretty neat set of data. from that, you on the user input, you can actually further get even more relevant piece of information. So you do have a pretty good amount of data that you can pass to your large language model GPT-4 and generate. And this actually helps you generate pretty long passages also in pretty natural language, and it's actually very usable. So so we can actually see that as a demo here, but before that, does anyone have any questions?
Aren't you limited by the snippets, as in snippets are themselves outputs of some language model?
Yeah.
Right? So it's like you're kind of taking up their errors also when you're generating your output. If there are errors in Google's language model.
Yeah. So that is definitely there, but then you can outsource your thing, right? You can assume that Google will try to do this.
Are there any limits on like how often you can hit Google's search API or something?
No. So basically, all these APIs, right? They have their own costs. So this is like one of the things you have to see. They have their own costs, and based on that, you decide how many you can, possibly hit. But yeah, it's like it depends. Like SERP API is sort of expensive, but there are actually cheaper ones available on the market also. So you can use them, you can get the results, and they give you pretty much the similar JSON.
And how fast is it? As in, like at inference time, when the user asks, you are going to search for like 2-3 results and then give back the output, right? So it is time consuming, I suppose.
Yeah, it's slightly time consuming. Yeah. So yeah, so there are ways around it. So most of the time actually goes, if you're using a model like GPT-4, GPT-4 takes a little time to generate, but if you go for the smaller model like Turbo, the ChatGPT API, they're actually much faster. So yeah, one of the things that you asked was what you're limited by the amount of snippet you take. But then you can, what we are going to show here is like we're not only just taking that, we're also scraping links. So we're actually combining two things over here and trying to get a bigger source over here. So we'll start over here. So these are the steps we'll probably do. You have a user input that can be free form, like it's mostly a question, but can be a different thing also. What then we do is we need to extract relevant data from the SERP API. So what we do is we divide that user input into different topics, questions that you can then ask the SERP API. After that, what you do is you get all the data, then we do some scraping if needed. And once we do the scraping, after that we have a large chunk of data. We then filter it out using different filtering methods. Now over here you can use different filtering methods, like embeddings is like the most common thing, the OpenAI embedding endpoints. You can use that, filter out the different things, and then afterwards you can then use it for your final data. You pass it to the model for generation. So we'll just see over here. These things are set up. Okay, so let's try to write about something different over here. So we have this, if people have been following the Apple WWDC 23, you will see the different things. So let's ask GPT to write about it. So you have this input. Then this is basically a prompt that we've used. This is a simple prompt basically to just analyze the user input and put it into different questions. Since we are going to be using the ChatGPT, GPT-4 models, they expect the input in a particular way. Anyone over here who's interacted with the ChatGPT models via code? Okay, so you would know that they want the inputs in a particular way, and the input basically is, let me just show you over here. they have these different prefixes. So a system message, a user message, and then based on that they do the generations. So once you have those things formed, we can then just pass it to the model to generate. So for question generation, we're using a smaller model because you don't really need it over there. So you have these models, you have this set of questions over here, and this is the response. Now the other thing is we want to be calling the search engine API. So we are using API provider value SERP. It's a lot cheaper than SERP API. And you get a lot more credits for the amount of money SERP API charges. So once you have these questions, for each questions we're going to try to fetch the SERP data. So now you have your SERP data taken. It'll be a mix of questions, answers, and different things. So you have the questions, and you have some links. These links which we will be scraping. And what we decided to do over here is two things. So what we decided is whatever question answer you get, we pass it as it is to GPT, because that's usually an indicator. Since it's coming from the SERP itself, you can assume that it is very relevant. So we pass those snippets as is, but then we also scrape other results. So we'll just pass it over here. So we'll just segregate them into different things, and then we have those final links that we are going to be scraping. So for scraping, we use something which we did in-house using different methods. There are scraping libraries also available. You can use that. And this is basically the results you get from scraping. So you get a chunk of text, you get the title, you get your meta description, you get the date, you get the author. Now comes like the pretty underrated part of retrieval, and that is basically how you chunk your data. And because the main restriction is you cannot pass unlimited amount of data to the models, so you have to pass only the relevant piece of information. Also, you want to restrict how much information you pass, because the more data you pass, the more you're charged. So these things are there. So it's important of how you chunk, and when you chunk, how much information can you pass in those different chunks that are relevant to the things. So what we do is we use a simple chunking algorithm, but apart from that, what we do is we use the certain piece of information, and you can decide to do it upon your use case, whether the headline or the meta description, stuff like that, how valid it is. But usually headlines are pretty valid because they give a big indicator of how relevant this piece of snippet would be. Just remove duplicates, simple duplication, and then we go for re-ranking them. So re-ranking is this is one of the models that was released by Cohere AI. You guys have used Cohere AI's models? How many have used? How many are hearing Cohere AI for the first time? Okay, so Cohere AI is another one of those big companies which is there. It's not like in OpenAI. OpenAI is, you can say, the leader in generation, but Cohere has a lot of useful models for embeddings, retrieval, those kind of things. So they're pretty good. So we're using one of their models for retrieving, and what we do is then we retrieve the relevant passages from there. Yeah. So based on the score, we take the ones, the top ones with score. So now we have like a lot of model, a lot of data here. So we have these many chunks, we have those questions. Now we want to filter it out and take a limited amount to pass to our LLM. So this is just a random number we taken, like say from all the passages you will take up to like 3000 tokens. We're taking tokens, so we are not characters. So for token is basically it's a subword, like a combination of characters. Using that for tokenizing, you can OpenAI has released this open source model of theirs which tokenizes based on which model you're using. So you can just use that model. We just use it as it is. It actually helps. And then we feed it in the final thing to feed in the prompt context. Yes. Okay. Converted into a string because pass strings, and then this is your final context that you will be passing to GPT. Again, for generation, we have our own generation prompt. We then again same thing we do over here, form a new generation prompt, add the message, use generation, and then finally you pass it over there. This is actually for all the steps, this actually takes the most time. The previous steps actually take less than 20 seconds to finish. This can sometimes takes time. So this is a weekend, so hopefully we get less load. Yeah.
Why do you use GPT-4 for this?
Okay, so one of the reasons you use GPT-4 is actually very good at this. Like you can use different models for this, but GPT-4's performance on these tasks is actually higher than other models, and to put it in production or to use it commercially in a product, a lot of the open source models, they're not as useful for this use case, at least the results for the users. So we've used GPT-4. There's also other models over there. So
Is it visibly better than 3.5 for small contexts like this one?
Yes, it does hallucinate less. But the new model that was launched like 3 days ago, that's also actually pretty good. So we haven't run enough experiments on that, but we are rolling that out. That's cheaper and much faster also. So you have your result. This is the old result. Just go over there. And let's just put it over there. So once again, so after all that, you can get OpenAI to write something on a topic which it hasn't been trained on. So yeah, that was the whole demo, and I can take questions now.
Do you limit the number of sub-questions generated for a particular question?
Yes.
Abhinav, can you repeat the question so people will
Do you limit the number of sub-questions generated for a particular question?
Yes. So generally you do, I mean generally we used to limit it. Sometimes it does require more. This is something which is use case based and also cost based. Generally 3 is like a pretty magic number that works. 3, 4, this works.
So was it like experimental or just like?
Yeah, lot of stuff. At least what I do and what we do at Longshot is experiment, see what the user's response is, and if you see a lot of cancellations, then you know it did not work.
See, Ankur is sitting there and he's also watching whether, like, he will not reveal any secret source, so that's why he's noting down in whether.
No secret. Secret was working for 2 years. So, have you seen that re-asking the LLM, giving it the context that, this was the context and this was your answer, are you sure it is right? Have you seen that help decrease the errors even more, or decrease the hallucinations?
Yes, but that is pretty expensive, more expensive because more time taking. I mean, there is like a cost you have to balance between how long you get the response and how long users get pissed off.
So I think this makes sense when you don't know what sort of queries you get. So, but in production, if you can probably profile the queries you get, can you cache a few of them in a vector data store? And is that what you do in production?
So semantic caching, are you asking about semantic caching?
Yeah.
So we are actually starting to look at that. I think Rohit is not here, but usually Rohit is someone in portkey.ai, if you've heard that one. Yeah, so we actually started working with them. Semantic caching is something that they are working on, and that is something which we'll see how it works for reducing costs. Yeah.
Is that the process followed in production once you are at a certain volume where you can profile the queries you get at scale?
Yeah, that would be there. Currently, it's not there as much because it's a very hard problem to solve. It's not as easy.
Can you speak a little to the challenges?
So one of the challenges is when you try to see how similar the thing is. It's the models over here, right? When you look at semantic embeddings, these models are very good for search, but they're not as good for similarity. So if somebody asks a question of something WWDC 23, then someone asks WWDC 21, they are actually pretty similar, and the similarity score is also very high because it doesn't understand numbers, and also it doesn't understand the difference between the two ones as well. So this is something that we want to see of how this works. These kinds of things are there, but there are other places you can sort of cache. You can maybe cache the results, but even in search results you have to look at, you don't want to keep it forever cached because Google pages change. Yeah.
So you mentioned that OpenAI is good for generation, Cohere is good for retrieval and all. Do you have some other models which, because we are unaware of any?
Yeah, so GPT-4 is state of the art, and no matter what people say, that is the best model. The new model which they released, 3.5K, the 16K context one, that is good, and we'll see how it goes. Like, it's pretty fast, and it's better than the Chat GPT model which they released in March. If you can get access to, like, say, Claude from Anthropic AI, that's actually also very good.
At any particular fields like retrieval or embedding?
These are mostly for generation. These are all I'm talking about is generation. Embeddings, you have the OpenAI embeddings which are pretty low cost and they do a good job. You have Cohere, and then there are of course SBot, for everyone using open source models.
Also, does the vector database you use matter, is all within the same quality?
So over here we've not used any vector database. No, so with vector database, if you want to try to go with the approach of putting it in a vector database and doing it, always know that like retrieval from a vector database is not going to be the best. Like it's an approximate retrieval, so there will be errors over there. So regardless of how you do it, you will have to perform a second set of ranking so that you get your more relevant results from there. So but yeah, you can try different vector databases, Pinecone, etc. They're there, but you will also have to see your infrastructure costs, their uptime, and yeah, those things.
Okay, let's one more last question. Yeah, then we can move on others.
I'm quite curious about how you evaluate these models, like given this hallucination, or let's say for long text outputs, right?
Mm-hmm.
So like let's say you do some innovation, like of course cancellations is one way to figure out how well you're.
That is the best way.
But in general, like when you're experimenting, especially when there is long text involved, what is like your strategy to evaluate?
Yeah, so we have different set of APIs also that we use over there. So this is one thing that we do, but another thing that we do is fact checking and claim detection, which basically what it does is tries to see all the relevant piece of information over here, which you can see, like say the Vision Pro cost over here. So take that, fact check it, see what the results are, is it relevant. Those things are there, and if the model does well according to that, it will work well. The other thing there is with the models over there, with say Text DaVinci 002, the prompts that we found working with 002, with 003 and the other models, they started getting better at retrieving and performing lesser hallucinations. So that's one way of doing it. Like you run different tests, you see how it works, and you can get it done. Okay, so that's it from my side. Thank you.